Last part of the moment of inertia, parallel axis theorem. Now, parallel axis theorem, the example is, consider a rectangle of side A and B. If I will ask you what is the moment of inertia about this axis, that is the x-axis which pass through the CG, then you tell me A P Q by 2L. This already we have derived in this part. If I ask you what is the moment of inertia of this axis, that also some extent we have derived, that is A P Q by 3, moment of inertia of this axis, that is A B Q divided by 3. If I will ask you moment of inertia about this axis, we don't know the formula. What we have to do? Again we have to derive. By taking the strip integration about this axis, we have to derive. Now it is quite difficult to, and same problem with this example also. If I will ask you the moment of inertia of the circle which pass through the center of the circle x-axis, pi r 4 by 4. The polar moment of inertia is something different, that is pi r 4 by 2, I x and I. But if I will ask you what is the moment of inertia about this axis, this x-axis which is join the bottom of the circle, that also you don't know. Now it is quite difficult to remember all the formulas. Now what is parallel axis theorem? Parallel axis theorem states that if we know the moment of inertia of the centroidal axis, just give the importance to this word, not any other axis. If I know the moment of inertia of the centroidal axis, then moment of inertia of an axis which is parallel to this axis can be given by I is equals to Ig plus AH square, where Ig, that is Mi about centroidal axis, not any other axis, centroidal axis. A, total area of figure, total area of the figure. H, distance between two axes. Two axes mean that is the centroidal axis and the axis where you want to calculate the moment of inertia. Now, application for example 1. That means for a triangle, this is the centroidal axis Ig. This is any other axis where I want to calculate the moment of inertia. Then H is distance between the moment of inertia of the rest to be calculated and the centroidal axis. This is the H, and A is the area of the figure. Example 1. Here nothing else is there. In between this proof is there. Proof is not important, that you can refer from a class note for the proof. Example 1. Mi of rectangle about its base. Moment of inertia of a rectangle about its base. That already we have calculated AB by 3 by integration method in the first lecture. We have calculated, my class note, I have calculated AB by 3 by integration method. We have find the formula, but here we found. Now if I give any other axis, we cannot do all these things. Now let, how many formulas also you can remember? You remember only one formula. What is the moment of inertia of any figure about the centroidal axis? You remember AB by 2. That you remember. If you remember that one, you can find any other axis. Okay. Then we know I is equals to Ig plus AH square. That is equals to. Now about this exercise I want. Moment of inertia Ig, that is A B Q by 2L plus A, area is A into B, area, into H square. H. S is the distance between these two axes. How much it is? It is B by 2. b by 2 whole square. That is a b cube by 12 plus b square a b cube by 2 square 4. That is LCM is 12. So it is a b cube. If I take common, 1 plus 3 by 12. That is 4 a b cube by 3. No need to integrate it. If you remember the formula of the centroidal axis, any other axis, if this axis, if I give you this distance, let's say h1, you can also calculate. That is a b cube by 12, a b cube by 12 plus area is again a into b into h1 square. That is the moment of inertia. That is the beauty of the parallel axis theorem. Only one numerical, in your book 2 numericals are there. 2 numericals I already read in the class note. Here one we will discuss. But prior to that, one more example let me take. Moment of inertia of a circle about its bottom. About this one, I. How much? Now this is the centroidal axis. Now this moment of inertia we know, that is pi r4 by 4. Now by using the moment parallel axis theorem, I is equals to Ig plus a h square formula. That is equals to Ig, that is pi r4 by 4. That formula we remember, but we don't know what about this axis, this axis. Plus area is pi r square, area of the circle, pi r square, into x square. What is it? The distance between the two axes, parallel axis and axis where you want to calculate the moment of inertia. That is r by, that is r. So it is r square. So it is pi r4 by 4 plus pi r4. That is pi r4 by 4. That is 1.25 pi r4. That is the answer. That means if I remember the moment of inertia about parallel centroidal axis, any other axis which is parallel to the centroidal axis, easily we can compute by using the parallel axis theorem. But remember, using this formula, the one of the axis must be the centroidal axis. This is not applicable. If I know the moment of inertia of this axis, let's say, or if I give you a one numerical, one particular example, if I know the moment of inertia about this axis, that is the axis which passes through the apex of triangle, this moment of inertia, let's say I know, I cannot compute the moment of inertia about this axis. I cannot compute. I cannot use this moment of inertia because this is not the centroidal axis. That you remember. But little bit doing, we can find it out. Okay, that one we will do. That is not required for you, but still then, if you want to know, just 2 minutes. Let this is the Ig. I don't know. This also I don't know. This is Ig. This is Ix1. I know. This is Ix2. I want to calculate. But I don't know Ig. But I can write Ix1 is equals to Ig plus a h1 square, where h1 is the distance between Ix and Ig. Similarly, I can write Ix2 is equal to Ig plus A, because area, total area, that is every time it is same, divided by these two, H2, A H2 square. If I subtract these two, Ix1 minus Ix2 is equal to Ig cancel, A common H1 square minus H2 square. That means if you know the CG point also, if you know this one you can calculate, but it is not a direct method, because you know that here also I use 2 times the parallel theorem. By mathematics I calculate, which is coming from this area. So if you know the centroidal axis, then only you can use the parallel axis theorem by using the formula I is equal to Ig plus AX square. Not one axis I know, other parallel axis I can calculate. One is the centroidal axis. Otherwise, simply 2 times parallel axis theorem I used. As after that, I use the mathematics to calculate. Now, if you know Ix1, Ix2 can be calculated. This one I can calculate. But if I know the centroidal points, H1 and H2, because that also you know, if total height is H, this one is H by 3, this is 2H by 3. So, the concept is that much only. Let us take, and these numericals are important for the exam point of view, because all of them may come 2 mark or 3 mark objective questions, but here you can get a long question. In this part, definitely you will get a long question, 5 mark or 6 mark question. That questions 1 or 2 questions, let us see. Easily you can solve others. Question. So let me take a numerical of your book. mm total, 80 mm, let's say 10 mm. This one is also, let's say 10 mm. Okay, similar questions I have given in your class note. Let me take so that I can use the values for that one. Okay, this one only. Find the moment of inertia about centroidal x and centroidal y axis. Find the moment of inertia about centroidal x axis and centroidal y axis. The question is this one. Find the moment of inertia about centroidal x axis. Remember listen the question, and centroidal y axis. Now, first of all, where I should calculate my moment of inertia? At the centroidal x axis. For this figure, the centroidal x axis is CG point. Let's suppose here this is the, if a line passing through the CG parallel to x axis is the centroidal x axis. But thing is that I don't know the CG of this one. So to find the moment of inertia, first one I have to find out its CG. So this will come in the longer 6 mark or 8 mark question. Similar question will come. If the figure is symmetric, you can find out central axis at the middle, but here it is not symmetric figure. So first work is find CG. Then I can locate the centroidal axis. After that I can start solving. So let this figure I have divided into 2 regular figures, figure 1 and figure 2. You know how to find out the CG. So figure 1, that is a rectangle. Area A1 is 80 into 10, that is 800 mm. X1 is 80 by 2, that is 40 mm. Y1 is, so first of all, to find it out, this is my reference axis. That you know always it takes from the corner, reference axis, this one. So Y1, that is 10 by 2, that is 5 mm. Similarly, figure 2, area A2 is 100 minus 90 into 10, 900 mm. X2 is 10 by 2, 5 mm. Y2 is already you know CG 10 plus 90 by 2, 55 mm. It lies at the middle CG of this figure, so it lies. So it is 90 by 2, 45. But I have to calculate from this reference axis 10 plus 45, 90 by 2, that is 55 mm. So XC is equals to formula you know A1 X1 plus A2 X2 divided by A1 plus A2, and similarly YC is equals to A1 Y1 plus A2 Y2 divided by A1 plus A2. Now you see A1 X1, A1 X1, A1 Y1, A1 X2, A1 X2, A2 X2. Similarly, A1 Y1, A1 Y1, A2 Y2, everything is there. You can only put the data, you can compute. So I already compute the value. XC is coming 21.47 mm and this is coming 31.47 mm. You can check 31.47 mm. So I can directly write the answer. So our coordinate is determined, x coordinate. So CG lies somewhere this point. Let me draw the centroidal x-axis, which lies at a distance. How much? 31.47. The CG point lies. This distance is 31.47, and here to here the x coordinate, here to here the coordinate is 21.47. This is the centroidal y-axis. 21.47. This is the centroidal x and y axis. Now question, he has asked me to calculate the moment of inertia above these axes. So first we calculate the centroidal axis. So I don't require this one now because my reference axis is marked. So let find out mi about centroidal x-axis. That is this one. So can I say my Ix, that is the moment of inertia about the centroidal x-axis, is Ix1 plus Ix2. What I did? That is because this is a composite figure. I don't know the formula etc. for this L section. Entire formula I don't know. So again same thing, I divide two triangles. So Ix1, moment of inertia of this rectangle about this axis. Moment of inertia of this rectangle about again this axis, x-axis. Now see Ix1. Now when you are solving, no need to draw other diagrams, but for you first question, for your clarification, let me do Ix1, that I am talking about moment of inertia of this rectangle, whose dimension is 80 mm and 10 mm. 10 mm. And about which axis I am trying to find out moment of inertia? About x-axis, this one, which lies at distance, how much? About the base, lies at a distance 31.47 mm. Now about this axis, I have to find it out, my moment of inertia. This is the Ix1. So what to do? Moment of parallel theorem. Ix1 is equal to Ig plus AH square. That is equal to the moment of inertia of this rectangle about its centroidal axis. That is easily you can tell me BAQ by 12. That is 80 into 10Q divided by 12. Remember, don't confuse 10Q or 80Q. The side which is perpendicular. Perpendicular side is always take the cubic power. 80 into 10Q by 12. From this axis it is 80 into 10Q plus what I require from this axis. So I have to go for the parallel theorem. A into H. A, area is 80 into 10, that 5. H. What is H? H between the distance between two axes. This is H. How much it is? H is equal to, yes, 31.47. Because 31.47 about the base, but I require from here to here. So here to here is down to central axis is 10 by 2, 5. 31.47 minus 5. Is it correct? 31.47 minus 5 whole square. You can get the value. Similarly, Ix2. Now if you want, you can pause, you can solve yourself also. So this one we can calculate. Answer is there later, like you can check the lecture note. Ix2. Now this again is not required, but if you want you can do. Otherwise you can see from that there also. Now this is the centroidal axis. This one is 90 and side is 10. From here to here height is given 31.47. Now its CG lies, okay, the diagram is not looks like. The CG lies somewhere at middle, that is the centroidal axis, okay. Little bit it is not looks like the reference. Okay, 31.47, here is the base. CG lies at the middle. Then this height is how much? 45, because total is 90. So CG lies at a distance 45. Excuse me.
And some power problem. So this is 45. Now which one is your H? H is the distance between these two. That means here I want to calculate my moment of inertia, and this is the Ig, the moment of inertia I know. H is the distance between them, which is 45 minus 1.47. So Ix2 is Ig plus AH square. This H is different from that H. So Ig is for this triangle, which is 10 and 90. 10, this side is 90. The 90 is not 1. This is 31 point, entire 90. So it is 10 into 90Q. I told you the perpendicular side. 90Q by 12 plus area is 10 into 90 into a square. H is now 45 minus 31.47. Hardly matter. Call this minus 1 because the square is there. If you take 31 minus 45 also, minus square is always plus. So don't bother about that thing. So you can calculate Ix2. Now after calculating Ix1 and Ix2, now come to this line. So Okay, the power cut problem is there. Another 1 minute is equal. So Ix1 and Ix2 we compute. Now comes to our thing. Ix is equals to Ix1. Ix, the total moment of inertia is Ix1 plus Ix2. So simply we have to add Ix1 we have calculated here, Ix2 we have calculated here. So this Ix the moment about inertia about central axis Ix 1 minute. So Ix is equals to Ix1 plus Ix2. So simply you add these two quantities, the answer is coming. Class note you can refer 1672990. 1672990 millimeter to power 4. That is the answer. So some other 1 or 2 numerical this kind I have given your class note. You refer that. No need to solve it because technique is same. You can understood if you do. Thank you.